module, I will present to you the topic entitled Quality Control. So for this topic, there will be 3 parts or 3 videos, and I hope that you could watch and understand all the videos. A little bit about me, since we cannot meet and I'm giving the lecture through videos. I am Puan Musilawati Muhajir, Senior Science Officer in Hospital Pakar Kanak-Kanak UKM. So I'm based in Pusat Perubatan UKM. I'm more to chemical pathology area, in which I'm handling the quality of tests in chemical pathology together with the analyzers and equipments that are related to the test. So any query, you can email me as shown here or WhatsApp me at number 018-2011-249. I repeat, 018-2011-249. So for this part, I will discuss with you the basic of quantitative measurement testing. First of all, the purpose of diagnostic testing is for screening. It is to detect early risk of a disease. It is also for diagnostic. When the doctor suspects that the patient had a certain disease, then he will conduct a diagnostic test to confirm his guess. Diagnostic testing also is used to monitor the progress of a disease or treatment, whether the patient becoming better or worse after a period of time getting the disease or after the treatment. It is also used for prognosis, that is to predict the disease condition in the future. Sorry. Okay. So let's go to diagnostic test. There are plenty of diagnostic tests nowadays. Some of it are qualitative. The results that come out is after observation, such as in histology, where the specimen is stained and examined under microscope. The result also could be in positive or negative, like in microbiology test. For this kind of test, the quality management may be easy. However, test operation is tedious and needs to be done in strict manner because there are various external factors that can influence the result. Remember, most of qualitative tests are done manually. Some of diagnostic tests, are in quantitative. The results are in quantitative form that we can see in clinical chemistry test, hematology test, and many more. The results could be in number, such as number of cells, concentration, example of units is micromole per liter, or percentage. The test quality management is much more tedious. However, the operation of the test may be easy since it is done automatically by analyzer or equipment. Okay. Now I'm going deeper into the quantitative test because these are the tests that perform the quality control activity completely. Most of the tests require reaction between specimen and chemical or reagent. As we can see in the slide, this is the specimen. The doctor requests certain tests on the specimen. For clinical chemistry test, the test is to identify and quantify certain substances in the specimen. These substances are called analytes. So I might be using the word analyte after this, okay? When the chemical or reagent reacts onto the analyte, the chemical reaction effect happen, such as changes in color, sedimentation formation, increase or decrease particular compounds, and many more. This will lead to chemical reaction product. The chemical reaction product represents the analyte of interest. the chemical reaction product need to be measured if we want to know the concentration of analyte of interest. Okay. There are many types of test reaction, or what we call as test principle, such as chemical reaction. Specimen is reacts with the chemical, or specimen is reacts with the enzyme as reagent. Potentiometry, such as such as ion selective electrode, amperometry and coulometry. Chromatography, that consists of affinity, partition, steric exclusion, ion exchange, and electrophoresis, and not to forget immunoassay. Okay, table here show the test reaction or test principle and how the chemical reaction product or the analytes is measured. Let's see here, for chemical reaction, chromatography in immunoassay, it is measured using spectrophotometry, nephelometry, tubidimetry, chemiluminescence or fluorometry, while potentiometry, it is measured by using the electrochemistry, and electrophoresis, we use densitometry. So, how to measure the analyte? You have the device, you have the chemical reaction product. So, how it is work? So, look at this example. There are two buildings. We know that tower A is higher than tower B. How much tower A is higher than tower B? Now, if we put the ruler, we know the difference between the tower, right? Conclusion? Well, we need ruler to quantify the difference in height. So, no ruler, we are unable to measure the height. Ruler is a tool where the scale has been standardized and adopted worldwide, if you want to know. So, go back to our case. To measure the analyte, calibrator is like the ruler. Without calibrator, the test reaction product cannot be measured. So, in this slide, we have specimen with the analyte of interest of glucose. We react it with chemical, which produce chemical reaction product. Then we measure the chemical reaction product using spectrophotometry, which give the reading optical density of 3. So, what is the glucose concentration? Remember, the spectrophotometer produce optical density only. So, let's say you have some materials with definitive values. We call this as calibrator. We have here absolute glucose material with the concentration of 5 millimole per liter. Deionized water, which has no glucose, so 0 millimole per liter. Then we measure it on the spectrophotometer, which give the reading absolute glucose of 5 millimole. OD reading is 5. Deionized water 0 millimole per liter. So the OD reading is 0. So, from that reading, we need to develop a graph called calibration graph. The calibrator of glucose concentration, x-axis, versus the optical density from spectrophotometry, y-axis. Then we plot the reading onto the graph. Absolute glucose, which have the concentration of 5, and OD of 5, while the deionized water have concentration of 0 and OD reading of 0. So, from here, we make a best fit line. So, if we have the specimen and the glucose OD of that specimen is 3, what is the concentration? If you can see here, OD3 will give the concentration of 3. Yes, the glucose of this specimen is 3 millimole per liter. So what is calibration? It is an important process that links the analytical signal with the concentration of analyte. Calibrators or standard material is either single form or series of solutions at known concentration. Calibration results will be used to develop calibration graph. This calibration graph will show the relationship between the concentration of the measured analyte and the magnitude of the optical or any signal given by the measuring device. So for calibration graph, it can be linear or non-linear, depend on the test reaction or test principle. So for calibration process, as I have mentioned before, but we just go through again. First, we need to run the calibrator and obtain the single value. Then we plot a graph of concentration versus the signal value and use the calibration graph to measure sample or specimen with unknown concentration. So calibrator is a material with specific concentration. The concentration is based on certified reference material or standard reference material in which traceable to test reference method. Usually, calibrators is produced by manufacturer that supply the reagent and analyzer. There are bodies that regulate tests that are conducted worldwide, such as CLSI. This body determines the reference method to measure the analyte. From reference method, CRM or SRM material is produced. The CRM or SRM material then is purchased by the supplier to produce the calibrator material. This is how the supplier ensure that their tests are traceable to reference method. So the calibrator material then is supplied to the user or laboratory. Laboratory then use the calibrator to set or adjust the test on the analyzer. So for standard reference material SRM or certified reference material CRM, it is a material with biological base. It is less pure than standard material or chemical with the purity is less than 99.98%. It is because the purity process will destroy the analyte of interest. Example of SRM or CRM is like bilirubin, ALP and TSH. And we must note that the concentration of this material, the SRM and CRM, is established using the reference method of the analyte. Okay, for standard, it is highly purified material that is usually not serum or plasma based. Example is calcium, sodium, acid hydrochloric and glucose. Sometimes it is also used as calibrator for the test. So there are two types of calibration actually. One is the test calibration that I have mentioned and discussed with you just now, which is where we use calibrator or standard material. Another calibration is for instrument or device calibration. It is done during the periodic preventive maintenance. Example, when we calibrate or setting the lamp, when we set the pipette of the analyzer to set the volume, or when we do the setting, the movement of the machine component. So, the components in clinical chemistry testing, as I just discussed with and we go through again. First, we need the specimen, in which the specimen contain the analyte of interest. Of course, we need chemical or reagent to detect the analyte of interest, and the reaction between the chemical or reagent towards the analyte or specimen is called test method or test principle. Of course, we need SRM or CRM and calibrator. We need, of course, the water as a medium, pure water. We need analyzer or medical device to do the testing automatically. And lastly, last but not least, we need quality control. So, how to determine that a test system could produce an accurate result? So, this is where the quality control take action. It is a system design and used to assure that the analytical process is performing in accordance with expectation. It is to verify what? So, I will discuss that on part 2. So, with that, I end the part 1 of quality control. Thank you. See you again.